Okay, welcome back, folks. Here's the second video about systems of nonlinear equations. In this one, we're going to do a more complicated example, not very much so, and a word problem, an application problem. So here we've got this problem, x squared plus y squared equals 25, and x squared minus y equals 13. Now, if we look at it, we could go either direction, substitution or elimination. This one's pretty good for either. You can see that if we did subtraction, we could eliminate the squares of x very quickly and easily. But if we move y over here and 13 over there, we could have y isolated and do substitution just as easily. So what do you think would be easier? Yeah, I don't know. I'm going to do subtraction. I'm going to do elimination right now because I have a feeling that's going to be a pretty quick way to go. So I'm going to subtract this whole side. I'm going to circle it so I remember that's what I'm doing. I don't forget in the middle of my problem. And I'm going to realize x squared minus x squared, well, that eliminates. There we go. Now y squared minus negative, oh, those are not the same, are they? They're not like terms, so we can't combine them. So that's y squared minus no other y squared. So we have y squared. Now we would have no y minus negative y. So that's minus negative y becomes plus y. And then 25 minus 13, that's 12. Now we can see we have a quadratic. And what do we do when we have a quadratic? We make it equal to what? Yep, 0, exactly. So let's move that 12 on over. And since it's a plus 12, we'll add it. So we would then have y squared plus y minus 12 equals 0. Now at this point, I think we could probably factor this. So let's go ahead and give that a try. Y something, y and something is 0. Let's see, 1 and 12, that's not going to get us to a 1y. 2 and 6 isn't going to get us to 1y. 3 and 4, that's 1 apart. So let's see, if we did 3 and 4, we have to get negative 12. So one of them has to be negative and one of them has to be positive. And to add up to be positive, we need the larger number to be positive. That outer would be 4y, inner would be negative 3y, and that would add together to be our plus 1y. So there's our factors. And again, using the zero product property, you guys probably remember we would set y minus 3 equal to 0, and y plus 4 equal to 0. Go ahead and move those values on over, and we find that y equals 3, and y equals negative 4. Now again, like we learned in the last problem, our solution set, these are parts of our solutions, but they're not the whole solution set. That's not an x and a y, that's a y and a y. So what we know right now is something comma 3 and something comma negative 4. We need to find the x value still. Now again, since we did elimination, we haven't isolated the other variable like we would have in substitution. That would have been a nice shortcut there. But let's see, looking at this, since we want to solve for x, they're both about the same. I really don't see much difference here. Let's go ahead and use the lower one. So let's say that x squared minus y equals 13. And again, x squared minus y equals 13. And we'll go ahead and plug those two y values in. So y is a 3 and a negative 4. So let's see, x squared minus 3. Let's move that minus 3 over here by adding it. So we get x squared equals 16. And then now what happens? If we square root both sides, what do we get? Did you say x equals 4? Who put the square root in? You. What do you need to remember? If you put a square root in, you've also got to remember plus and minus. So that's a plus and minus 4 that goes with that 3. So what's that saying? That's telling us that this 3 has two different x values. So we have another value here. We should have a positive 4 with the 3 and a negative 4 with the 3. We're going to have to take a look at that graph to see how that is. You know what's going on, don't you? That's a circle and that's a parabola. Okay, we'll get back to it. Okay, so back up here, when we finish this one up, let's see, what do we got there? Let's use the purple here. That's a plus 4, minus negatives plus 4, so let's subtract it on over here. So we get x squared equals 9. Again, we're going to put the squared in, and what are we going to remember? You got it. Yes, plus and minus. Good. So we've got x equals plus and minus 3. So again, that means that our negative 4 value here has two different x values that go with it. So we need to go there, and we're going to put in another negative 4. So now positive 3 goes with negative 4 and negative 3. So we actually, in this case, got 4 answers. Let's take a quick look at why that is. So if we graph it here really quickly, that's a circle with a radius of 5. I know we haven't done much with conics yet. Algebra 3 kiddos, I know you've seen that. So it's just a circle centered at the origin with a radius, the square root of that number, which is 5. So we got a circle like that. Okay. Now this one, again, remember, what did we do? Well, we never did do it. But if we move the y over here and move the 13 there, we actually have x squared minus 13 equals y. So realize what that is. That's a parent parabola that's just moved down 13 units. So if that's 5, it's down here 6, 7, 8, 9, 10, 11, 12, 13. And then it's going up. And I'll bet you it's going through 2 points like that, right? So it would be going through 1, 2, 3, 4, 3, negative 4, 3, and then 1, 2, 3, negative 4, and 1, 2, 3, negative 4. And that would make sense that this would be a little closer in, and these two are a little further out, right? So that's what's going on in that problem. Now, again, that just had more answers to it, and I wanted to remind you of the plus and minus when you do the square root on both sides to get rid of a square. That's how you end up with 2 answers there. You've got to remember that. Okay? Now, in this problem, we've got a computer monitor, and we're told that the area of the monitor is 12 inches squared, and that the diagonal is 5 inches. It's a 5-inch monitor, okay? We want to know what are the length and the width of that monitor. So we have to come up with 2 equations with 2 variables. So we're looking for length and width. Those are our 2 variables, right? So what is area? Well, area is length times width. So we can write L times W equals 12. And there's our first equation. Our second equation has to do with this guy. And if we remember, since it is a monitor, that's a right triangle. And we can use the Pythagorean Theorem right now that leg squared plus leg squared equals hypotenuse squared. Or in other words, length squared plus width squared equals diagonal squared. So we could say length squared plus width squared equals diagonal squared. So now you've got your 2 equations, and you have a choice to make, substitution or elimination. I'm going to let you make that choice, but I'm going to tell you this, that getting L or W by itself is going to give you a fraction of 12 over that number, which is probably a really good way to go. Over here, you don't really want to move something and then square it both sides, because now you're introducing a square root in your problem as opposed to a fraction. Deal with the fraction instead of the square root. It's going to be a lot easier to do. So I'm going to get you started, and then I'm going to let you ask me later if you have more questions. So like I said, what we would do is we'd take, I don't know, let's just take the W. Let's take the L and move it over and say width equals 12 divided by length. So now we know the width. Let's put it right there. So we would get length squared plus width squared. That's going to be important to remember that square there in a minute. Equals 5 squared. Let's go ahead and multiply that out and call it 25. So we know the W right here is 12 over L. So what we've got to realize now is we've got to square this fraction. It's okay. L squared plus 144 over L squared equals 25. Now this might be looking weird to you right now, and I get it. We're going to make it quadratic-like. So here's the technique. We can multiply both sides of an equation by the same thing, right, as long as it's not 0. So let's multiply both sides by what's going to clear out our fraction, the denominator, L squared. So if we multiply both sides by L squared, and then distribute it in. This gives us L to the 4th plus. Now this cancels. 144 equals 25L squared. So this is a quadratic-like equation. So all we're going to do now is we're going to move this 25L squared over there by subtracting L to the 4th minus 25L squared plus 144 equals 0. And now we would use that idea of variable substitution, if you remember that. See, this is something squared, half that power, and a constant. This is a quadratic-like problem. So what we could do is we can think of this guy, the middle, L squared, as the variable u. So if we do that, then L squared is u. To get L to the 4th, we'd have u squared. Minus 25 will substitute u. Make that a 5. There we go. Plus 144. We can factor this, and we factor it into u and u and 0. Let's see, 144, 1 and 144, no. 2 and 72, no. 3, nah, it's just not going to work. But I'll bet you 9 times 6. 9 times 6 is 144. And if we do minus 9 times minus 6, we get positive 144. But they add up. 9 and 16, my bad. Thought I had that all remembered, huh? 9 and 16 multiplies to be 144. And that adds up to be the negative 25. So now resubstitute u with L squared, and you're right back to your original L squared minus 9 times L squared minus 16 equals 0. And oh my gosh, guess what? I hope the alarms are going off because those are differences of two squares. Those are two specials that you should have memorized, right? This factors into L plus 3 times L minus 3. This factors into L plus 4 times L minus 4. And you can now see L equals negative 3, positive 3, negative 4, and positive 4. There are 4 values for the length. Plug them into here or here and find the other for the width. But notice what's going on. Negative values for length? That doesn't make sense. Those are extraneous, huh? So in the reality of the word problem, we can eliminate those two and just plug the 3 in and the 4 in. If you have a length of 3, the width is 4. If you have a length of 4, the width is 3. It just depends on which way you've oriented your monitor that you're looking at. So there you go, folks. That's how to do a word problem there. You basically are looking to write your 2 equations and 2 variables. You just may end up having squares in there as well. So I hope this is all helpful. I have your homework for you. Homework is to read and take notes on page 843 to 850, a couple pages there, and it's problems 1, 19, 29, 43, and 55. For your joke for the day, I got your popsicle joke. What do we got? Yes. Why did the song do well in school? Why did the song do well in school? Because it took a lot of notes. Take a lot of notes, folks. Talk to you later. Bye.